This is a pear leaf. It can be identified by its shiny surface, and the edges of the leaves are smooth, and there's no serrations typically, or they're very, very fine. So similar to an apple in form, pear leaves are typically cupped or concave on top. Lighter green on the bottom. That's a graft I did this spring. And this update is on the grafts I put on the pear tree. An odd thing happened. When I put the grafts on the pear tree, I made a mistake. I thought that an apple scion that I was putting on was a pear scion. So I actually grafted apple onto pear. Now, if you ask anybody that knows anything about grafting, can you graft apples to pears? The answer they will give you, or should give you, is no. That's mostly the truth. The truth is that they're not compatible grafts, and that typically the grafts will fail, and maybe almost immediately. The reading I've done, the longest I've heard of a graft surviving is like 3 years. So I made a mistake, but let's not call it a mistake. Let's call it an experiment. Yeah. Okay. So the experiment gone wrong is this one here, or the mistake is this one here. As you can see, a pear leaf. Okay. Shiny leaf, smooth edges, and up and up and up we go. And here's the graft union. And then we get up to here, and I'm going to sacrifice one of these leaves or two. Get it in the shade here. Maybe you can see it better. Maybe sun is better. That is an apple leaf. Notice the serrations on the edges. Okay, definitely different than a pear leaf, if you know what you're looking for. So we have a Jana DeCoster. That's a Jana Gold growing, and I have 18 inches of growth this year on my apple scion growing on a pear tree. Do I expect it to survive a lifetime? No. Short life, yes. It would be really interesting if I could get an apple from it. All the tree is feeding that apple scion, that apple branch now, is just nutrients it needs. So the scion itself, or the graft itself, I'll let you be the judge on it. It's not the most perfect match, and it may be brittle. I don't know how it will fail. Chances are it'll just die. It's sort of like grafting, or like transplanting, somebody's liver into somebody else's body. It doesn't always take, but not always right away. So the interesting thing is that I had these Jana Gold DeCoster from Brian. Thank you, Brian. And the odd thing is that I grafted it to like 3 different pear trees, and all the grafts did work. So they're experiments, and I'll keep you updated as they go. It would be really cool if next year I actually had a spur on one of these branches and I get an apple before the graft fails. That would be really interesting. The only reason that a graft may work and may not is the following, as I understand it. Apples and pears are similar, and they're kind of like dogs. Okay. Dogs, once upon a time, were probably nearly the same animal. Dogs and say wolves. Okay. And at some point, ancient man decides to domesticate a wolf, so he captures a puppy and he raises it, and he breeds them, and the puppies he has from that first generation of wolves, he takes the mildest temperamented ones, and the reason being is because he doesn't want to wake up some morning and have his pet dog chewing on his leg bone. So you simply pick a trait in an animal that you want, and you continue breeding that trait to other like animals until that recessive gene becomes a dominant gene. So that's how we have dogs of all different shapes and sizes and colors now. Now the problem is that the original dog had a lot of genes, okay, and they get sort of bred out and they become recessive. And it makes later successive generations possibly not compatible with each other, compatible with maybe the predecessor, or the originator of the new species, but not all other animals that came from it. So we have a Saint Bernard and we have a Chihuahua, both the ancestor of some wild dog or wolf. And the reason that they're not compatible now is because, well, on the one hand you have a Chihuahua, and on the other hand you have a Saint Bernard, and the reason that they're not compatible is because they find each other repulsive. Yeah, that's what it is. So they're not compatible. And but there can be other reasons than just size. Okay, hundreds and thousands of reasons why genetically two species that are the one species. I don't know if I'm using the correct term there. Species, family, whatever. But now they're not compatible. So at one time, I expect that pears and apples came from the same father or same mother, and they have differentiated. We have European apples, which came mostly from Kazakhstan, I believe, and we have, or that survived the longest there, and then were transported around the world and bred into good tasting apples. The apples, native apples in Kazakhstan are crab apples. So they've been bred and the traits have been passed on that people liked, which is typically sweetness and largeness and whatever. And pears also probably changed, or they changed from it, because if you look at Japanese pears, they're round like an apple, but they taste very mild like a pear. So they're probably halfway between the two. And there's probably, if you're going to experiment with grafting between apples and pears, probably Asian pears would be a better, I'm thinking, because at least there's one characteristic that they have more in common with an apple, and that is their roundness. And if you can match the most traits up, you probably have a better chance. Although you're hoping that certain traits go with other traits, like the roundness goes with the more compatibility to an apple. You know, from a roundness of a Japanese pear to an apple, because traits are passed on in short segments of chromosome, and a piece of chromosome that splits off carries several traits with it. So that might be what you do, is take an Asian pear and try and graft it to an apple. You might be more successful. The graft may last longer, and you might work better to graft an Asian pear to a apple that is mild or in flavor similar to an Asian pear. So maybe a golden delicious, maybe something with wild apple genetics would be better, because it would have more genes that it needed to match successfully. I have the reading I've done that the best match of an apple to a pear is a winter banana apple grafted to, I believe it was a Bartlett pear. It might have been a Bartlett pear to a winter banana apple tree. And the graft lasted for 3, maybe 4 years. Maybe we can increase that, I don't know. But pears and apples typically are too far apart to be grafted together successfully. Where'd it go? Oh, here it is. I did a little bit of experiment years ago. I will update this experiment. Here in my pear tree is an apple, a Jonathan apple. That is, I think, the last graft. It was grafted right here. The graft doesn't look all that healthy, and the limb doesn't look all that healthy. The tip is dead. Looks like it's dying back. I grafted, I don't know, 4 or 5 Jonathans onto this pear tree by accident, and I thought it was a pear sign I was putting on. I left them. Most of them have died since.